biosafety, we define biosafety as the principles and practices implied to protect laboratory personnel and the environment from exposure or infection while working with living organisms, biological materials or agents. This is the proper definition of biosafety. Now, we define the risk as the lack of certainty about the outcome of making a particular choice. This is the definition of the risk. Another definition that the which has been defined by the risk management standard, and they define the risk as the chance of something happening that will have an impact upon objectives. Risk is measured in terms of consequences and likelihood, or we can say that risk is the likelihood of an undesirable event happening that involves a specific hazard or threat and has consequences. Risk is the likelihood of an undesirable event happening that involves a specific hazard or threat and has consequences. Therefore, risk is a function of both the likelihood of something happening and consequences of that occurrence. Now, what is likelihood? Likelihood is the state or fact of something's being likely. Simply means probability. What is consequences then? Consequence is a result or effect, typically one that is unwelcome or unpleasant. And we also talked about the threat. So, what is threat? So, threat is the possibility of an unfavorable event to occur as an expression of target to cause evil, injury, disruption or damage. So, what would be hazard? Hazard may be a source, situation or act with the potential for causing harm. Hazard may be a situation, for example, fire or explosion. Hazard may be activity, for example, we are doing pipetting. Hazard may be from biological materials like biological agent or toxins and biological waste material. Chemicals and gases such as nitrogen, these are sources of hazard. They are hazards and they are sources of hazard. In this subject, we mainly talk about the management of the risk associated with biological materials. So, the risk associated with biological material is called biorisk, and the potential source of harm caused by biological agents or toxins is called biohazard. Now, certain biological materials are the assets. Certain biological materials are the assets which require specific attention for the protection and monitoring in lab and have the potential to cause harm in the population. These are called valuable biological materials like anthrax, poliovirus, which has the fear to be stolen, misused or released intentionally from the lab. System or process to control safety risk and security risk associated with the handling or storage and disposal of biological agents and toxins in labs and facilities is called laboratory biorisk management. According to the World Health Organization, the WHO defines the biorisk as the analysis of ways and development of strategies to minimize the likelihood of the occurrence of biorisk. This is the WHO definition of the biorisk management. Thousands of infectious biological agents and toxins are handled and processed in an assortment of labs types for diagnostics, clinical research and commercial purpose around the world. The type, number and quantity of such materials are dependent upon the scope and nature of the work conducted in these laboratories. Now, each agent and toxin handled is a potential hazard, posing a risk to the personnel in the lab and facility and likely to the surrounding animal and human communities beyond the lab. Thus, it is the responsibility of all labs, facilities who are working with valuable biological materials to operate safely and securely. Then the first step in achieving this operational goal is to assess the safety and security risks present in these labs. Biological agents and information developed to better health, welfare or safety could be misused for harmful purposes to cause damage to public health, safety and the environment. So, the biorisk management describes containment principles, technologies and practices to protect people from biological agents and prevent accidental release of biological agents. In addition to biosafety, lab biosecurity measures aim to prevent theft and intentional or malicious use of biological agents. Thus, both biosafety and biosecurity should be an integral part of program management in order to prevent undesired spread, theft or malicious use of the dangerous pathogens. Now, dear students, remember that there is no such thing as no risk in this world. There is no such thing as no risk in this world. There is always risk. There is always risk. So, the risk must be identified. The risk must be evaluated. The risk must be measured and plan to minimize the risk. When we say safe, it means the risk has been judged acceptable. Judging risk is subjective. Humans make decisions. Measuring risk is subjective, using available guidelines, data and documentation, keeping the record of how determinations were made due to subjective nature of the process. Dear students, next we are going to discuss the biorisk management and its components in detail. I am going through the slideshow here. So here we start the biorisk management in detail. The biorisk management or BRM has three main components: assessment, mitigation and performance. BRM is equal to assessment, mitigation, performance, or BRM is equal to AMP. Why we do assess the biorisk? The aim is to achieve the highest practical protection and the lowest practical exposure. The biorisk assessment include hazard and threat identification, hazard and threat analysis, level of biological risks, likelihood and consequences evaluation. Hazard is synonym to danger, risk, chance of danger and chance of risk. It is defined as any source of potential damage, harm or adverse health effects on something or someone under certain conditions at work. Or, according to the World Health Organization, hazard is a danger or source of danger with the potential to cause harm. The source of hazard could be a knife, this is a thing, a material like pathogen, condition like wet floor practices, like pipetting, substance, chemicals, source like electricity source. It's a source of hazard. Process like culturing. Hazard may be physical hazard, chemical and gases hazards, radiation hazards, biological hazards. Biohazard, as already we discussed, any biological material which poses the potential to adversely affect the health of humans, animals, or environmental. Our environment is called biohazard. Examples include all the viruses, bacteria, fungi, parasites, means the pathogenic microorganisms, blood and blood products, tissues and body fluids, cultured cells, allergens. Those chemicals or materials which cause allergy or allergies is called allergens. Toxins like the bacterial toxins, fungal toxins, plant toxins. Amongst the bacterial toxins like the tetanospasmin or something like that, the fungal toxins, aflatoxins produced by Aspergillus flavus. The plants produce many toxins which are called phytotoxins. Clinical and diagnostic specimens are examples of biohazards. Similarly, infected animals and animal tissues are the examples of biohazards. Now, to further elaborate, the term hazard is used mainly in the biosafety context, and the term threat is used mainly in the biosecurity context. Threat is the situation or substance when intends to create harm. For example, a loaded gun in the hands of a stranger pointing to your head. A loaded gun in the hands of a stranger is an hazard, but it becomes threat when pointing to your head. So threat, as already discussed, that intentions are involved. So in biosecurity perspective, threat is the intention of someone towards valuable biological material to create harm to humans and environment. For example, stealing of anthrax spores for malicious intentions. Now, analysis of the hazard and threat. So actually this is the frequency and magnitude of the hazard and threat. Hazard is the biological material worked with within the lab. So we are here analyzing the hazard and threat. So how we are doing that? If a biological agent is highly communicable with inhalation route and a procedure is being implemented where large volume aerosols are being generated in close proximity to the lab worker, and protective equipment such as respirators or biosafety cabinets are unavailable, we can say likelihood of exposure is high. If that same biological agent does not produce serious disease, and furthermore an effective vaccine has been administered to all personnel, we can say the consequences of exposure are low. The threat is the potential adversary who is interested in the biological materials. Here we are analyzing the threat. So what is adversary? Individual with malicious intent or a person or group that is hostile to someone. That person or that group or that individual has enemy-like attitude towards someone. This is called adversary. So characterizing potential adversaries allows one to determine important parameters for likelihood and consequences, such as means, motives, and opportunity. Example include the use of physical barriers lower the likelihood of threat. Availability of therapeutics lowers the consequences of threat. How we analyze hazard? So the hazard is evaluated by means of the following properties, which you can see here: agent risk groups classification. For example, the pathogenic microorganisms have been classified into 4 risk groups, which we are going to discuss in the next few slides. So what is the risk group of the particular agent or agents? Route of infection means that the pathogen is transmissible in the route of inhalation, in ingestion, or cutaneous. Infectious disease process means incubation period. Pathogenicity of the pathogens or the microorganisms, virulence of the pathogens, quantity, concentration, infectious dose, lethal dose, incidence in a community outbreak. If a certain type thing happen, so what will be the consequences in the community? What will happen to the community? Is it will produce or bring an epidemic in the community? Presence of factors, availability of preventive measures and effective treatment, for example vaccines and antibiotics. Potential outcome of exposures means the whether the people are recovering from the disease or the disease or the exposure is lethal. Stability of the agent in the environment, which is known as thermostability. Similarly, we analyze threat as presence of valuable biological materials. I told you in all my classes that whenever we have something that is asset, then we need to protect that asset. So if there are valuable biological materials, we need to protect those assets and those materials, because those materials have the pose, if stolen or misused, they can cause huge harm and they can cause huge damage to the population. So presence of adversary in the area means conflict of the nations, conflict of the people, foreign invasion, insurgency, etc. Level of training of the staff, level of experience of staff, workload and fatigue. This is the most important thing I discussed with you earlier in the class, that workload and fatigue, how the workload and fatigue becomes a threat for the workers or the surrounding environment. Health and immune status of the workforce, good laboratory practices, housekeeping and cleanliness, use of biological safety cabinets, use of personal protective equipment, proper decontamination, waste management, occupational health, administrative controls, presence of the agent in the environment around the laboratory, immune status of the community, population density of the community, presence of suitable host or vectors. All these points we have discussed in a good detail in the regular classes. If I go a little ahead, this is some of the pictures I have already displayed you. Now, classification of infective microorganisms by risk groups. So risk groups have been classified into microorganisms have been classified into 4 risk groups. So risk group 1, which is unlikely to cause disease in humans or animals, no or low individual risk or community risk. Risk group 2 include those microorganisms, pathogenic microorganisms which cause disease, but the diseases are typically not serious. So similarly, risk group 3 microorganisms may cause serious diseases, usually treatable. The diseases are serious but usually treatable, and these microorganisms or these pathogens are mainly the respiratory tract pathogens. Risk group 4 include those pathogenic microorganisms which cause serious or fatal diseases, and those diseases are often not treatable. The transmission of these risk group 4 microorganisms is very easy, high individual and high community risk. Effective treatment and preventive measures are not available for these groups of microorganisms. To evaluate the likelihood, we have to consider agent, the procedure happening at the lab, and mitigation measures or biosafety measures. It can be explained as in the next slide, which I have for you people. This is the risk group slides. Agent risk group. First, we have to know about the risk group to understand that the transmission, to understand the pathogenicity level and the virulence of the pathogen. Then as I told you that to evaluate the hazard, we consider the properties of the agent, laboratory procedures, and mitigation or biosafety measures. So here, if you look at this table, properties of the agent include mainly the infectious route, infectious dose, and stability of the agent. Similarly, what kind of procedures we are doing in the lab? For example, we are doing culturing or isolation, we are doing pipetting, we are injecting something, we are going to diagnose something, we are going for serology, ELISA, we are doing for the confirmation or PCR. So, and on the other hand, we what kind of measures we have in the laboratory, which includes the engineering controls, all the materials and all the things from the floor, from the design to the electricity and everything. It comes in the physical things which we see in the lab. These are engineering controls. So engineering control, biological safety cabinet, whether in the lab here or the biological safety cabinets are present or not there, available, not available there. Similarly, the sealed flasks, HEPA filter exhaust, personal protective equipments, administrative controls, policies and procedures. These are the biosafety measures or mitigation measures. So any increase and decrease in the above all will alter the likelihood. How? Here is one example, that if the hazard has inhalation route of transmission, the likelihood will increase. But the same hazard, if manipulated in biosafety cabinet, the likelihood will decrease, and vice versa. So in hazard evaluation, we can simply say that we can evaluate hazard according to the available resources with us in the lab. If we have the resources available, as clear from the example, if a pathogen is transmissible through inhalation route, and we do not have biological safety cabinets, and we are conducting certain works or diagnosis process or research for the research purpose or diagnosis purpose, so then the likelihood will be high. But if we have biological safety cabinets with us and we use biological safety cabinet for the purpose, then the likelihood will be less or decrease. So similarly, the consequence is the environmental impact of an event occurs. Consequences refer to the impact of the pathogen on human and environment. Consequences can be evaluated by means of understanding the agent, vulnerability of the community, availability of therapeutics and prophylaxis, etc. Properties of the agents include, again, route of transmission of the pathogen, virulence, pathogenicity, stability outside the host. Similarly, transmission between humans and animals, mortality, morbidity, case fatality rate, etc. In addition, general health status of the community, prophylaxis availability, etc. Prophylaxis means treatment availability of to the community, etc. So amongst the three components, we covered the assessment so far, which include the hazard and threat identification, hazard and threat analysis, level of biological risk, level of likelihood and consequences evaluation. All these points we discussed in detail here. So this was about the first component, main component of the biorisk assessment, biorisk management program. Said. So the second main component of biorisk management is biorisk mitigation. The dictionary meaning of mitigation is the action of reducing the severity, seriousness, or painfulness of something. Here, from biorisk mitigation, we mean that actions and control measures that are put together to eliminate or reduce the risks associated with biological agents or toxins. Or we can say that biorisk mitigation is a process through which we reduce risk that we identified during the risk assessment to ensure biosafety and biosecurity. Mitigation is based on the risk evaluated and the degree of risk. The prime objective of the mitigation is to ensure biosafety, the biosafety of the individual, biosafety of the population, biosafety of the environment, and biosecurity of the valuable biological materials. All the mitigation measures come under the following types or classes of biorisk mitigation, and these are elimination and substitution, engineering controls, administrative controls, practices and procedures, personal protective equipments or personal protective equipments. So here we are highlighting these things in a little bit detail. So amongst the types or classes of biorisk mitigation, the first one is the elimination and substitution. Elimination is the decision to remove the risk. For example, killing of rabid dogs, culling of bird flu affected flock, or eradication of cows in case of mad cow diseases. And similarly, not working with Congo virus in a laboratory with BSL2 facilities. In biorisk management, the substitution is replacement of more hazardous with less hazardous. It's the replacement of one thing with another which is less hazardous. For example, use of low pathogenic organisms rather than high pathogenic organisms. And similarly, using nitrogen cylinders for semen storage instead of ultra low freezer. Another example is replacing mouth pipetting with automatic. Elimination or substitution, or both elimination and substitution, is the most effective means of mitigation. The second one type or class is the engineering control. Engineering controls are the physical changes that are brought to workstation, equipment, materials, and production facilities to reduce or prevent exposure to biohazard. For example, biological safety cabinets, autoclaves, sharps containers, personal protective equipments, facility ventilation or airflow, physical security of the facility or the lab, which include the access restrictions, that limited access or only authorized person can enter these area. Similarly, CCTV is also a physical security. The third one in the physical security is facility and equipment locks, badge readers, detectors and sensors, biometric devices. These are the things in engineering control inside the in the physical security. The next class or type of mitigation is administrative control. The administrative controls are the policies, standards, and guidelines that are used to mitigate risk. It includes qualified, trained, and competent personnel, hierarchy, well-defined terms of reference, accountability, check and balance, implementation of standard operating procedures, health and safety programs, for example, vaccination to the workers in the lab, emergency response and contingency plans. These include precautions against natural disasters, provision of emergency equipment, for example, protective clothing, disinfectants, identification of responsible persons and their duties during the emergency times, shifting of exposed or infected persons to hospital in case of emergency, and emergency treatment of exposed or injured persons. So these are the points in the administrative controls. Some other main points which are included in the administrative controls in the biorisk mitigation. These are the biological agents and toxins inventory management requirements, which include the record of data received on each chemical container and maintenance of inventory of chemicals stored in lab. Similarly, annual update of inventory list. The next point, or the next main thing in the administrative control, include the waste management policies. So, which include the waste storage containers, color coded bins, plastic bags, etc., and waste management handling, transportation, and disposal. Security policies, facility security, visitors access, personal security, access to biological agents and toxins, data security. These are the main things which are included in administrative controls. Practices and procedure is also a main type or class of the biorisk mitigation. The processes and activities that are practiced to reduce biorisk. These are this is not a different topic from the rest of the things we studied and we discussed here. These practices and procedures are processes and activities that are practiced to reduce biorisk. Example, standard operating procedures for all safety and laboratory biosecurity relevant processes, good laboratory safety practices, which include training before starting work in the lab, no eating and drinking, use safety cabinets, proper labeling of lab equipments, location of emergency exits, standard operating procedures for each test equipment must be displayed, name tags for every person working in the lab, and unauthorized person must not to enter the lab. These things which are included here in the practice and procedure, these things are, we will discuss these things again in the good microbiological techniques, which we call GMTs, or good laboratory practices. We will discuss all these things there in further detail, inshallah. Also in practices and procedure, use of appropriate disinfection and decontamination practices. All items in the biological safety cabinets, including equipment, should be decontaminated before and after use. The work surface and interior walls must be wiped that must kill microorganisms. Similarly, transportation procedures for infectious materials and specimens, which include the packing, marking, and labeling. Specimen and reagent handling and storage practices ensure that everything required to take sample is accessible. Specimen and reagents should be properly labeled. The head of the container must be properly screwed to avoid any leakage. Persons handling the specimens or reagent must use proper personal protective equipment. Emergency exercise drills, similarly training on the safe and secure handling of biological agents and toxins. These are the practices and procedure which we should follow, which we should strictly observe these things in the while we are going to mitigate the biorisk. And mitigation of biorisk is the second main component in biorisk management. So next here we have some snaps to show to you people relevant to these things we discussed here. Example, this is here is a snap of threat, hazard, risk while during the pipetting or pouring the mixing the reagents. Similarly, relevant to the physical security, these are the CCTV cameras. Similarly, we have to lock the equipments and lock the doors and main gates of the labs. These are also amongst the physical security of the lab. Next type or class of the biorisk mitigation is personal protective equipments, to which we call PPE. These PPE or devices are gear worn by the workers to protect against hazards in the lab, which include the things or equipments for eye protection like safety glasses, face shields, goggles, etc. Respiratory protection, we use face masks, N95 respirators, face shields. For hand protection, we use gloves. Body protection, we use lab coats, uniforms, overalls, surgical scrubs, rubber boots, disposal shoe covers. And these are the few snaps of these things. And inshallah, in the personal protective equipment chapter, or the inside the topic of the good microbiological techniques, I will demonstrate to you that how to wear and how to remove these equipment and things in the laboratory, to which we call donning and doffing of the PPE. Inshallah, I will demonstrate these things to you people. Next is the third main component here, that is the performance. So performance is the third main component of biorisk management. Now, to check that in the biorisk management, during the assessment process and during the procedures and SOPs followed for the mitigation, whether the system is working the way it was designed or not. To ensure this, we come to check and evaluate these things, and this we call performance. So performance is the implementation of the entire biorisk management system, including evaluating and ensuring that the system is working is the way it was designed. Another aspect of performance is the process of continually improving the system. So why we are discussing this performance? Because to know that system works and is sustainable and that the risk is acceptable. Performance has been divided into three parts: control, assure, and improve. So control is the continuous procedure of monitoring for lab work adopted by the lab staff for releasing the reliable results. To manage biorisk, there are certain steps which we should consider in the control. These are the policy, which means what to do. And next is the procedure. The next step in the control is procedure, how to do. The third step in the control is the organizational structure, means hierarchy. The fourth step in the control is the responsibility, which means who to do, what to do, and when to do. The next part, the next part of the performance is assure systemic process of checking through audits and inspections. And this process can be done on weekly, monthly, or quarterly basis to check the results and impacts of the actions taken for biorisk management through pre and post analytic phase, test, standardization, performance evaluation, accident incident investigation, inspection, and audit. And senior leadership reviews the biorisk management system and at planned intervals to ensure its continuing suitability, advocacy, and effectiveness. The review shall include assessing opportunities for improvement and the need for changes to the system, procedures, policies, and objectives. Records from the management review shall be maintained. The management review should be conducted at a defined frequency determined by the needs of the organization, but at least annually. The review input should include information on results of audits, compliance to SOPs, status of risk assessment activities, status of preventive and corrective actions, follow-up actions from previous management reviews, changes that could affect the system, recommendations for improvement, results of accident or incident investigations. Similarly, the review output should include decisions and actions related to the improvement. So this was all about the assure, which is the second part of the performance after the control. Now we are moving a little ahead to the third part of the performance, that is improvement. Improvement, this is actually the improvement of the effectiveness of the biorisk management system. Improvement related to the requirements and risk assessment. Improvement regarded or about the needs of the resources. Improvement with respect to goals based on internal and external feedback. So here we have this slide in which we have covered all the three components of the biorisk management, which are the assessment, mitigation, and performance. This is a systematic approach during each and every part or component. When we go for planning, doing the things, checking the things, and acting upon those things, this is called a systematic approach. So in assessment, plan, do, check, act. Similarly, in mitigation, plan, do, check, act. And in performance, plan, do, check, act. So the plan, do, check, act, PDCA is a tool of quality control. So mitigation is improved and sustained when performance measures are included. These are some of the points like pre-analytical specimen collection, transport and processing, analytical testing, post-analytical testing, results transmission, interpretation, follow-up retesting. So these are the points which can improve the mitigation, and which we can sustain the biorisk management process or program in an effective way. So test standardization is achieved when test results with the same high levels of accuracy and care can be reproduced across measurement systems, labs, and over time. Standardization depends on a careful process using reference material, proficiency testing, training, guidelines, consultations, etc. Similarly, lab shall establish and maintain documented procedure to define, record, analyze, and learn from accidents and incidents involving biological agents and toxins. The purpose of an incident investigation is to find out what happened during the incident, why it happened, and determine what steps should be taken to prevent a reoccurrence or recurrence. To be effective, the active participation of supervisors and workers is essential. The organization shall ensure that a program of inspection and audit is conducted which is appropriate to the risk associated with the facility. Inspections and audits shall be conducted at planned intervals to determine if the biorisk management system conforms to the documented plans and to the requirements of this agreement, and that is effectively implemented and maintained. Management responsible for the area being inspected or audited shall ensure that any action is taken without undue delay to eliminate detected non-conformities and their causes. So dear students, it was a revision of the work we have done, and I tried to present all these things we have done in a summarized form, and hope you have learned and your memory would have been recalled by this. So you should not be bored. You should ask me here in the YouTube. You can ask me in the comment, and you can ask me in the WhatsApp group of your class, and that would be more better to ask in the WhatsApp group, so all the rest of the people will discuss the things easily. So thank you for watching, and thank you for your patience, and I pray for God from Allah that may Allah protect us all from the COVID-19. Stay safe, stay blessed. Thank you very much.